Test. Testing. Is that better? Did I fix it now? Test. Oh, there we go. Sorry about that, guys. Now there's sound. Cool. So, yeah, so we're really excited for this workshop today. We are doing a full stack blockchain application, end to end. We're doing front end and back end. This was definitely really highly requested. We're really excited to be doing this. We're really excited to be working on this project. We have a couple of different ways that we can go with this. Similar to how on the back end we can use hard hat, we can use truffle, we can use brownie, we can use all these different frameworks. On the front end, it's the same thing. There's way more frameworks than what we're going to go over here. And we'll kind of go over a couple of different examples to get you spun up with the front end really quickly and get you guys going there. So it is 8:04. We have a lot to cover in this. So let's go ahead and jump right into it. Boom. Cool. So let me show you first what we're going to be working on today. So we're going to be working on something like this. It's a contract. It's an application that allows us to stake our different tokens. So we can stake. These are kind of the different tokens that we can stake, and then we can also get issued rewards based off of how much we've staked. So if you guys have ever seen anything like, oh, getting mad echo now though, huh? Let's see if we can fix that. Better, worse? Test. See if we can fix that. Did I ruin it actually? Better, worse? Test. See if we can fix that. Did I ruin it actually? Better, worse? Yeah, that's super strange, actually. Hold on. Is it better now? I don't want to keep going if I'm still echoing. Did I fix it, or is it still whack? Some quick audio issues here. Looks like I fixed it. Okay, cool. Woo. All right, thanks for pointing that out, though. Appreciate it. All right, let's get back into it. So here's what we're working on. It's an application that allows us to stake our tokens and then get issued rewards for it. So here we can see, like up in the top right, we have a reward balance. And this is similar to, like, you know, if you've ever seen, you guys have probably heard of liquidity farming or yield farming or liquidity mining or whatever. I don't. This isn't necessarily that, but it's more just giving some type of reward token based off of how much somebody has invested in your platform, right? For example, if you're like having like an Aave or a Unity or a Uniswap or something, right, and somebody has $100,000 invested in your application, you can give some type of governance token or something like that based on the value that they have in. And that's actually the important part of this tutorial, is that it's actually based on the value. So our FAU token, which is like our fake kind of dummy faucet token, is going to be pretending to be like DAI basically, and then Chainlink token is obviously going to be Link, and then we're going to have our DApp token, which is also going to be like a sort of DAI. So this tutorial is inspired by DApp University. If you guys haven't seen them, definitely go check it out. They are a sponsor of this hackathon. And they have a lot of fantastic videos here. So they're the inspiration for this. But without further ado, let's jump in into building this, and let's talk a little bit about the different front end approaches that we can take. Okay, so before we actually even dive in, so I'm a big fan of this package create ETH app. So after you guys do all your backend stuff, you do your brownie, you do your hard hat, you do your truffle, whatever, use after that, you use create ETH app to actually create a front end. And a lot of projects, you guys have probably seen this too, they do this in a separate repo, right? So they have one repo for the back end, one repo for the front end. In our demo here, we're going to do everything in the exact same repo. We can even look at Chainlink DeFi. Front end and the back end are going to be in the same repo. If that makes your life easier, absolutely go for it. And just put everything in the same repo. You don't have to do two repos, but it can be a little bit nicer to separate the two, have them in two different repos. But for developing, it's usually a little bit easier to have them in the same repo here. So that's just kind of a little note there. Another note is that if you're really struggling, there are a couple crutches you can use to build a front end. One-click dApp is a really nice one. You literally, I think you log in with MetaMask. You connect MetaMask. Yep, you sign in. And what you do actually, once you sign in, is you just add the name of your dApp, a description, ABI, contract address, and network, and it'll kind of spin up a really easy front end for you. So that's what I'm going to say first off. If you're if you know nothing about front end, know nothing about JavaScript, nothing about any of this stuff, one-click dApp is a really easy way for you to get started. Create ETH app is going to be a little bit more advanced. It creates a React.js front end, boilerplate for us to kind of go in and modify. This will give you all the bells and whistles. This will kind of be a little bit of a crutch. And of course, you can always use Scaffold ETH. This is almost like the midway solution where in your you can just add your contract to his contracts folder, and then on your front end in the React app, I believe he has a contract section. Or no, sorry, not the contract section. Maybe it's an app JSX. You can add your contracts in here, and that will actually have them render on his Scaffold ETH bit. But we're not going to go into that. One other example that I wanted to show you guys, just because I'm pretty proud of it, and it's really silly, but it's really fun. I have this one. This is an example of a front end I created with Create ETH app. It is the VRF Pizza front end. You're looking for an example of doing a front end in a separate repo outside of the one that's in the back end. So this is the back end. This is the front end. The back end is written with Brownie, as you can kind of see here. And the front end is with this Create ETH app. And you can see it has all the boilerplate of Create ETH app. But if you guys want to check those out as an example, you absolutely can. For kind of a different example. And this one, Create ETH app, actually uses, excuse me, close this. This VRF Pizza front end uses Create ETH app, like I said, and Create ETH app actually does state hooks and does a lot of the newer React stuff, whereas the example we're going to be going over isn't going to be doing state hooks or any of that newer stuff. So you're going to get a couple. There's a ton of different examples here for you to check out. And the other thing you can do is all this stuff is open source, guys. So this is actually one of my favorite parts of the blockchain world is everything is open source. So you can look up front. Well, maybe not. Yeah, but so this is the Uniswap front end right here, right? So you can just fork this, copy paste it, whatever you want to do, and you can see the front end of all these other applications. So all this stuff is open source, which is amazing. So if you ever want to just check out somebody else's front end, you absolutely can. And without further ado, let's learn how to do this. Let's get this started. So I'm going to kill it on my end over here. We're going to refresh, and we're going to be starting from blank. Let's do this. Are you guys with me so far? We're going to be going over a lot of stuff here. Let's see. Okay, cool. So let's get started, right? And a lot of our examples have been using Truffle. Let's just continue to start there, right? Let's do Truffle and box, smart contract kit / box. Get started just getting a sample box in here. And again, if you want to use Brownie, if you want to use Hard Hat, there are examples for both of those as well. So let's get it going. Let's do our contract sections first. And once we have our contracts up, once we have our contracts kind of being built, we can start doing the front end, right? Because we can't start doing the front end until we have the back end kind of up and going. So let's even just really quickly again look at what we're trying to accomplish here. What are these contracts trying to do? So we have a contract, right? That's going to be taking tokens, right? We're going to be sending tokens to this token farm, to this staking contract, right? We have a reward token, like a DApp token here, that we're going to be giving back to people. And do we need anything else? Or are those the only two that we really need? That's really all we need. We just need those two pieces because we can use existing tokens. We can use like the existing Chainlink token. We can use the existing faucet token, which we're going to pretend is DAI. A lot of people are often ask, hey, I'm looking for a DAI faucet. You can usually just, I usually just use what's called faucet token. I just pretend it's DAI. So they just give you like ERC20. You can just pop in your address here, amount 10, connect, metamask, mint free tokens, and you'll get this thing called faucet token. So if we look in your metamask, once we mint it, we'll get we'll get 10 more FAU. So it looks like it just confirmed. So now it's 1858. So this is what I use instead of like a DAI faucet. I just use this faucet token. So this is all we need. We just need two contracts. We need a contract that allows us to do all the staking, and then we just need a simple ERC20 to give rewards back. Now we also are going to want this platform to issue rewards. So that's going to be another functionality. So we need to stake. We need to unstake. We need to issue some rewards. And that's really it for the most part. We don't really need too many other bits. We do need to kind of allow the specific tokens that we want. So we do need to allow the addresses. But that's really it. So I'm going to kill this. And now we're going to start from scratch now that we kind of know what we're doing. So let's jump in here. So we have our contract section. We have a whole bunch of boilerplate in here, and we have a whole bunch of boilerplate scripts, a whole bunch of boilerplate migrations. I'm just going to go ahead and kill all this stuff. Goodbye. We're going to start from absolute scratch. Scripts. Yep. We're just going to start from scratch here. Are smart contracts in this box audited? No, they are not. These are created as is. So we're just going to get rid of all the scripts. We're going to get rid of the tests too. With the trash. And cool. So, and we'll even get rid of all the migrations. So we're starting from pretty much scratch here. Okay. Let's go ahead and we'll leave the test for now. So let's go ahead and create our first, the easier part of this demo, which is going to be the DApp token, right? This is just going to be an ERC20, right? And if you guys have followed along with some of the tutorials so far, you know pretty much the easiest way to create an ERC20 is just using OpenZeppelin. So we're going to do Pragma, Solidity, 0.6.0. We're going to import OpenZeppelin. I'm actually going to copy paste here just so I get it right. And again, OpenZeppelin, ERC20, if you guys check it out. ERC20 Open Zeppelin. It just imports some really standard OpenZeppelin code for us. so that we have a really easy way to create an ERC20. Oh, and sorry, actually, we're starting from scratch, so this will be empty. Yep. Okay, cool. So once we've imported from OpenZeppelin our ERC20, we can do contract web token. We inherit it is ERC20. We'll do constructor public ERC20. All we need to do is give it a name and a symbol. We'll call it DApp token. And we'll give it a symbol of DApp. DApp it up. And then we just call this mint function. So all this syntax I'm doing, you can check out the OpenZeppelin documentation to learn, what this looks like. But this is really the easiest to set up an ERC20. So we're going to mint toMessage.sender. They're going to be the owner, and we're going to do a big. I'm actually going to copy paste this too. A large amount of for like the initial supply. So if we go 1, 2, 3, 4, 5, 6, 7, 8, 10, the initial supply is actually what is this? 1 million. Initial supply is 1 million, right? Because remember, this is like in way, so those are there, and that's pretty much all we need for our contracts here. So let's do a quick truffle compile. See if this worked. Looks like we ran into an error. Let's figure out what the error is. Can I find module? Oh, okay. I should probably install stuff. Install with Yarn. So this is going to install all the stuff that you see in package.json and get us going here. Now, I am going to be skimping a little bit on the tests in the interest of time, but oftentimes writing tests as you're coding, as you're developing, is actually going to make your experience a lot better. If you've ever seen those videos where like you press a button and another button pops up, or like you fix one code or you fix one bug and like 5 other bugs get introduced, this is going to be a test is going to help you prevent from doing that, right? So tests are going to be really useful. And yeah, pretty much anytime you write some type of function, you put tests on it if you want it to stay like that. So for this DApp, we could put in some tests saying like, hey, is the initial supply what we expect it to be? Are we doing what we want here? But again, we're just going to skip over the tests in the interest of time. So let's do truffle compile again. Let's see if this compiles. And great. So it compiles. So we know we don't have any compilation errors here. Okay, great. So we have DApp token pretty much done. So when we deploy this, it's going to mint 1 million DApp tokens to the user. Okay, great. Now let's work on the harder one, right? And this is going to be, we're going to call this token farm. That's all. Okay. This is going to be the contract that has a lot of stuff in here. So let's just like define what it needs to do, right? Before we even start coding, but let's give it a pragma solidity solidity 0.6.0. And let's contract token farm. What do we need this to do? Let's think about this before we do anything. So we probably need a constructor, right? Constructor. Look. What else do we need? We need a stake tokens amount, right? We need a user able to stake tokens. What else do we need? Oops. We probably want an unstake token. We don't want to have our people forever permanently locked in here. So we'll call it unstake tokens public. And what else do we need? We probably want an issues rewards, right? So let's give it an issue or like an issue tokens. So we'll do function issue tokens. And what else? What else do we need? we probably want to get the token price, right? Because again, we're going to be issuing rewards based off the value of those tokens. So we'll say get token ETH price. Look. Anything else that we need? I'm looking at my boilerplate here. There are going to be a couple other functions that we need, but these are kind of the main ones, right? We want someone to stake tokens, unstake tokens, and issue tokens. I mean, these are our 3 core functions. So let's start building this. So great. So let's give this a name real quick. We'll call it string public name equals dep token form or not. And let's go into our constructor. So the reward token that we're going to use is going to be that dap token that we deployed. So we need a way to say, hey, the reward token is going to be this dap token. So what we can actually do is we're going to import the interface of an ERC20 into our smart contract. Again, we can go to Open Zeppelin. We're actually going to import this ERC20. This is the interface, and it allows us to interact with ERC20s really easy. Great. Glad to hear the volume issues are fixed. I'm sorry about that. So we're going to import some opens up in code, contracts token ERC20 ERC20.sol. And we're going to set a global ERC20 public dep token. Boom. And here, we're going to set the dap token equals ERC20 dap token address, and this is going to be a parameter that we pass. Address. Oh, and again, guys, feel free to ask a ton of questions here. These are meant to be engaging, and we're supposed to work together on this. But great. So we have our constructor, and once we deploy this contract, we're gonna say, hey, the dap token, the token that we're gonna use to issue rewards is gonna be this ERC20. Again, this is an interface, and it allows us to say, hey, this is an ERC20, and we're gonna set it to this dap token bit. So once we deploy this, we're gonna set it to this dap token. Great. Simple enough so far. Now let's go to our stake tokens function. This one's gonna be a little bit more interesting, right? So how do we actually have users stake stuff? So this is going to be something that a user is going to call. A user is going to call this function. So what do we want them to do, right? We want them to stake a certain amount of a token. So we probably need a couple things. We probably need an amount and the address of the token that they want to use, okay? So let's require the amount greater than 0. And if they don't give it an amount greater than 0, we're going to give an error saying, amount cannot be 0. And let's have them jump in. Let's have them start adding this token. Now, something that we probably should think about, though, is do we want people to stake any and all types of tokens? Probably not. We probably only want them to stake tokens that we've defined that are good, right? If you want it to be any token, you absolutely can, but maybe we also don't have a price feed for those tokens, right? If we don't have a price feed for those tokens, then we can't assess the value of the token. So let's create a new function called token is allowed, and this will give us an idea of whether or not the token is allowed. So we'll do function token is allowed, and it takes the address of the token. It's going to return Boolean, right? True if the token's allowed, and then false if it's not. So how do we actually figure out what tokens are allowed? Well, we probably need some type of mapping, right? Or some type of array that tells us which tokens are allowed. So let's actually create that array at the top. So we'll say there's an address array called allowed tokens. And this is where we're going to store our tokens. So you guys probably are going to see we're going to need like a store tokens or like allow tokens, right? So in our tokens is allowed function, token is allowed. We're going to loop around that array, and we're going to find the ones that are allowed. So we'll do a for loop, uint 256, call it allowed tokens index equals 0. Allowed tokens index is going to be smaller than the allowed tokens dot length. Allowed tokens index plus plus. And as you can see, we're already starting to kind of get a little bit big here, right? A little bit complicated. So let's even talk about word wrap real quick. And this is where, writing those tests as you go along is going to make your life a lot easier, right? Because if we do truffle compile right now, we're probably going to run into a bunch of errors. It's going to be like, what are you trying to do? You're crazy. And yeah, it's like, what? You spell things wrong. You can't, come on. 3 S's on address. Come on. Get it together, Patrick. So running these tests kind of as you progress, you can make sure, okay, this function is actually going to do what I want it to do. But again, we're going to kind of skip over in the interest of time. So we're going to loop through this array of allowed tokens, and we're going to say if allowed tokens index equals token, then we're going to return true. Right. So if this token is in our array of allowed tokens, then we're going to return true. Otherwise, we'll return false. Okay. So this is what this function is doing. And this is exactly like, you could write a unit test for this just to make sure, okay, like, am I setting this correctly? So we probably need a function to add allowed tokens. So let's add that function, add allowed tokens. Address of the token. Now, for this, we are going to have a manager. We're going to have like a token manager, right? Because we don't want anyone to be able to just add tokens. Maybe they're add some terrible token. But we do want to people to be able to add tokens. So maybe this would be done by a governance, a DAO. This wouldn't be necessarily the like the owner, right? Because this would make it centralized. This would be like the admin key. We're just going to do only owner for the sake of this demo. So only owner is a modifier. Hopefully some of you guys are familiar with it. It means that this function can only be called by the owner. We can actually import this from opens up one as well. I'm just going to copy paste. So this ownable contract, you guys can check it out. It has what's only owner. This is what the modifier looks like. It's actually really simple, but it requires that the owner is going to be message.sender, which is really nice. So we do have to inherit it as well, is ownable. All right, we got some questions. Can we use this code in production? It's not audited, so I would highly recommend you do not. This is provided as is. It's, hey, Patrick, why not use a mapping for tracking allowed tokens? A for loop would consume a lot of gas, no? Actually, yeah, that's probably much better. Yeah, that's probably way better. Now that you mention it. Yeah, I kind of want to, let's change it on the fly. Let's do mapping of address to Boolean, public, allowed tokens. Yeah, actually, A mapping would be better. I'm just going to keep going just so I can follow along with my demo here. But yes, a mapping would be actually much better and much cheaper and much more gas efficient. So yeah. I probably did something weird on the front end that wanted me to use a mapping or something. But yeah, you probably would want to use a mapping. So let's go back to our add allowed tokens. So we'll do allowed tokens, push. Or if you're doing the mapping, this would be like allowed tokens, token equals true, right? If you were doing the mapping, you would just do that. It would be really similar. If you were going to use something like NewCipher to encrypt the messages, is this where you would do that? I haven't worked with NewCipher enough to know the answer to that. Maybe, I'm not sure. So cool. So we have this function now. It adds allowed tokens. We have our is token allowed. We have our add allowed tokens. Awesome. Now we can go back to our staking. Function. So if token is allowed, yep, a mapping would be like 1,000,000 times better. If the token is allowed, we're going to do some stuff, right? We need to update unique token staked, which we'll get to in a second. We need to update the number of tokens that this address has, that this user has. Let's just do some boilerplate code. We're going to need to transfer the token. So we're going to say, we're going to take this token, dot transfer from message.sender, comma address. We're going to send it, we're going to transfer it from the sender to this contract by the amount. And then we're going to need a way to keep track of how much they've actually staked. So let's actually go ahead and create that as well. We're going to need to have these guys have some type of staking balance, right? So this is where we definitely 100% need to do a mapping, because an array would be insane. So we'll do a mapping of addresses to, and what do we want to do this a mapping of? We probably want to do this to a mapping of a mapping, actually. I don't want this spin your head too far. We're going to do a user, so it's going to be the user address, right, is going to be mapped to a mapping of token addresses, which is mapped to amounts, right? So we're going to do a mapping of address to uint 56 equals this. Okay. And we're going to call this public staking balance. Okay, so that's what this is going to do. Let's go back down to our stake token function, right? Because this is one of our most important ones. We'll come back to this in a minute. I'll show you why we need this, but let's pretend we don't care about that for now. So our staking balance and our stake token function. Staking balance of, actually, sorry, it's vice versa. It's going to be token address, excuse me, to mapping of user addresses to amounts. Sorry. So we're going to do staking balance of the token, but it doesn't really matter. You can do it either way. Message.sender will be equal to the staking balance of the token of the user plus the amount. Right, so we want to keep track of the staking balance of their token that they're going to send. So we're going to say the staking balance of the token message.sender is going to be equal to the same thing plus the new amount that they're going to send. So great, this is us keeping track of the staking balance here. And then we're going to do, we want to keep track of who all of our stakers are. So we're going to add this additional piece in a minute. I'm going to skip over it now. Unique tokens staked. But because this is, if you just want to add staking here without any rewards, this is really all you need, right? If the token is allowed, go ahead and have them transfer it. There's two other functions that we'll need. And again, we'll get to those in a minute. So great. So we have pretty much the boilerplate of the stake token function done. Again, we're going to come back to it in a little bit later. But now we want our users to be able to unstake tokens as well. So how do we actually have them unstake the token? So we'll do address token. So they're going to unstake a specific token. But first, we need to balance equals staking balance token. Sender. So we get their original balance. Now we want their balance to be greater than 0. Otherwise, we could say, you know, staking balance not be 0. And once we get it, we're going to do, again, to interact with these ERC20s, we'll do IERC20 of the token dot transfer sender balance. So transfer, just a quick note, why are we using transfer here and then transfer from up here? Does anybody know? I'm gonna wait like my 2 seconds for the delay to kick up, to peace out. Why are we using transfer in one place and transfer from in another? Does anybody know? Let's see. How clever are we? Does anybody know? Oh, sorry about that. If nobody knows, we can move on. So the reason we're using transfer down here, and then actually if you're watching this later, you know, pause for a second and be like, okay, why are we using transfer here, transfer from up here? Okay. So the reason we're using transfer here is whoever is initiating the function is going to be, okay, we have a couple questions here. We're unsure, okay. The reason that we're going to use transfer here is that we're going to call this unstake token, and transfer assumes that the sender is going to be message.sender, right? It assumes one is from the owner and the other is from the mint address. Transfer from is from someone after approve. Yep. So transfer from, we do have to do the approve, right? So up here in transfer from, we're calling the stake token function, but it's the contract that's actually doing the transferring, right? So we first have to approve that this contract can do this, right? Because we own the tokens. We own the tokens. So we're going to say, okay, we want to send the tokens from the sender of this to this smart contract, because we are the owners of the token, not the contract. In this case, who's the owner of the token? The contract is. So it doesn't have to, it can just send. It doesn't have to do that whole two-step process, right? Because it's the owner of the tokens. So that's the difference. This is when the contract owns the token, and the contract owns the token and it's moving the token. This one, the contract doesn't own the tokens, but it's moving the tokens. So that's kind of the difference there. That's why we need to use transfer versus transfer from. So anyways, let's do staking balance. The token sender. We're going to turn the balance to 0. We're just going to withdraw everything. And then we will need to do one other step, but we'll get to that later. So great. So unstake tokens and stake tokens. If we wanted to just send this, we probably could. We wouldn't be able to issue any tokens, but we could have people stake on our platform, and maybe we could do something crazy with their stake. But we want to issue tokens. We want to do that liquidity farming stuff. So let's actually do this issue tokens bit here. Okay. So how do we issue tokens? Well, we want an idea of who all the stakers are, right? So do we have any data structure where all the stakers are? Not really, right? We have the staking balance mapping, but this is a mapping. We can't loop through a mapping. We have an allowed tokens array, but that's just the token. So how do we actually keep track of this? Well, we're probably going to need another address array called stakers. This is where we're going to store all of the stakers. Now we have to go back in our stake tokens, and we actually have to update our stakers bit. Okay, so we'd have to do like stakers.push message.sender. But what's the issue here? If I stake the same type of token over and over again, I'm going to get added to this list a whole bunch of times. So we only want to update if there's a new unique token staked. Okay, so we're going to add this function called unique token staked. And if the user does have unique token staked, equals true. Here, actually, we'll count. If unique token staked is 1, if they're adding a unique token, if this is their first token, we'll do stakers.push message.sender. The number of unique tokens that they have is 1. We'll do we'll set it like we'll send it to 1. So we're only going to be updating here if this is their first token staked, but obviously we have to update the amount of tokens staked. So let's create this function, update function, update unique token staked, right? And what is this going to do? It's going to just add the number of unique tokens that they have, right? So we'll do address user, address token, and we'll have this be an internal function so that other people cannot call this, right? Only our contract can call this. And we'll say if balance token user is less than or equal to 0, what are we going to do? We're going to do unique tokens staked by the user equal to unique staked user plus 1. Oh, we need this unique token staked data structure. Let's go ahead and make that. We'll do mapping address to UN256 public unique token staked. That's right. Yeah, so if the staking balance of a user of that token is greater than 0, we're going to add it. We're going to add it to the number of unique tokens staked. So this is kind of a dangerous function, right? Because we're doing kind of a dumb operation here to update the number of unique tokens, but again, the code here is provided as is and isn't really meant for production anyways. So great. So we have this unique token staked. Now let's go back to our stake token function. Stake token function. And we need to give it the message.sender and the token. And we should probably do a semicolon at the end. I'm going to pause real quick. If anybody's super lost, I know I've kind of been coding for a little bit. And it's like, what are you doing? You are doing some crazy stuff here. Are there any questions from anybody following along so far? All right, it's a little bit delayed, so the questions might come in a minute, but I will look down in a minute. So we're still on to the issue tokens here. Okay, so now we have an idea of who the stakers are. Is it on GitHub? Yes, this is on GitHub. Boom, right here. Everything that we're going over is in here, and you can feel free to follow along in here if you want. So issue tokens. What we want to do is we want to loop through the stakers. 0. So let's loop through all the stakers. We'll do stakers index is less than stakers dot length. Stakers index plus plus. We should do this right. How do you use Solidity 0.6? Because my example was written in 0.6. That's really it. And haven't updated yet. That's pretty much it. Use whatever Solidity version that you want. A lot of the Chainlink core contracts work really well in 0.6, and I know they work well in 0.6. So that's why I've just kind of been sticking with it. Yeah, at some point we'll probably move. I'll do more examples in 0.8. 0.8, that safe math upgrade is actually massive. I'm really excited about that. But anyways, so what do we want to do? So we'll do address recipient equals, it's going to be the stakers index. And we're going to send some of our DApp token, right? This is going to be that that reward for them. So we're going to do DApp token.transfer recipient. But how much are we going to send them? How much are we going to send them? Oh, also, we definitely want only the manager to be able to call this. So only. How much are we going to send them? Well, again, we want it to be based off the value that they've staked on our platform. Okay? So we probably should have a function that checks the total value of a user or how much they've staked in the platform. So let's go ahead and create that function now. Do function is get user total value, address of the user, and this is going to be a public view returns uint256. Because we're going to be using this function to be getting the total value that a user has staked on a platform. So how do we do this? Well, conceptually, we just loop through all the tokens that they have staked on a platform, and we get their Ethereum equivalent in value. Okay, so let's go ahead and figure out how to do this. So let's do uint256 total value equals 0. And then if we want to be clever, we do like returns total value, but we're not going to be clever here. If we want to check, do they have unique tokens staked? Does this user have unique tokens staked? If yes, well, what do we want to do? Well, we're going to loop through all their tokens, right? And this is where a mapping would be a little bit hard, actually. Because if we had, this is where a mapping would be a little bit hard. So we're going to loop through the allowed tokens. And this way, we can always kind of go back and loop through, okay, how many tokens does this person have on our platform? So this is where an array actually does come in really handy. So uint256, allowed tokens index 0. Allowed tokens index is less than allowed tokens.length. Allowed tokens index plus plus. There's definitely some more clever data structures than this for doing this, but this is what we're going with for now, just because it's conceptually a little bit easier. So we're going to loop through all the allowed tokens. I'm going to check, hey, does this user have these allowed tokens? If yes, great. Well, let's get the value. So let's even do that right now. We'll do total value be equal to total value plus get user staking balance ETH value. This kind of disgusting function where they're going to take the user and allowed tokens. of the allowed tokens index. We're going to create another function here called get user staking balance ETH value. So what's this going to do? It's going to say based off the user and the token, this gives us the user and the token, how much is that worth? If I have 10 link, how much is that worth? If I have 10 DAI, how much is that worth? Right? We want to get that value so we know how much to reward them. So let's create another function. It's going to be this function here. It's going to be function get user staking balance ETH value. And we're going to take address of the user, address of the token. There's probably a better function we can do than this. We do public view, returns uint 256. And let's do this. So this is where getting the price of this token is going to be really, really important. Okay, so we don't have the functionality yet, but we will. So let's do this. So let's just do a quick check if the unique token staked user is less than or equal to 0. I'm going to return 0. So right, if they don't have any tokens, we're just going to be like, okay, you don't have any tokens, bub, beat it. But if they do have tokens, we're going to return staking balance of that token of the user. And we're going to multiply it by our function get token eth price token. And then we're actually going to divide it by 10 raised to the 18th. Right, because, oh, and then actually we want to even do it like this. Excuse me. We're going to get the balance. We're going to times it by its price, and then we're just going to divide by the precision here so that we can get the actual reward amount that we're going to send them. So let's create another function. Got a lot of functions here. Called get token ETH price. And this function, get token ETH price. So we're going to say based off the address of the token, public view returns in 256. Based off the address of the token, we need to get the price. So this is where the Chainlink price feed bit comes in. So we'll do address, price feed address. And how do we get the price feed address? Well, we're probably going to need to do some type of token mapping. So we'll call it token price feed mapping token. We'll actually have to create this as well. Top. We'll do mapping address to address, public token price feed mapping. And we're probably going to need a function that will set this up correctly. So we'll do function set price feed contract. We'll do address of the token. I'm actually going to go a little bit quicker just because I'm running a little bit low on time. Address of the price feed. Public only owner. We'll do token price feed mapping. Token equals price feed. Okay, so this is something that once we initialize our contracts, we're just going to set this up, right? Depending on the network that we're on. So let's scroll back down to get token ETH price, which I clearly have defined twice. Now here's where we did the Chainlink bit. Aggregator v3 interface. Price feed. And if you haven't seen this stuff, work with the price feed stuff, definitely go check out the documentation. Price feed address. So we want to be working with this Chainlink aggregator v3 interface. So we're going to have to go back to the top. We're going to have to import this. Great. Great, we've imported it. Now let's just get that price. So if we go back to the docs too, docs.chain.link, the price feeds using the latest price. This is kind of the functions that we have, and this is exactly what we're doing in our contract. Let's even just copy this because this is exactly what we want. Except for, yeah, price feed, the latest round data, and we're going to return, although we want a UN256, not an int price. So, great. So now we have the latest token ETH price. We have the user staking balance, user get total value. We can issue tokens. Oh, no, we can't issue tokens. Let's finish that. So what are we gonna transfer this person? We're gonna transfer the total value they have staked on our platform. So get user total value, zip p int. Boom. Now we have import what? Yeah, import the Chainlink library. Sorry. So this is how we're going to import Chainlink into this smart contract here. We're going to do this this import statement right here, so that we can work with the Chainlink price feeds. Good question. So now do we have everything? Got a lot of stuff in here. Let's do a quick scroll down, right? So we have DApp token, right? We have two arrays for stakers and the tokens that we allowed. Yes, we could do some mapping stuff here. We have 3 mappings that we want for our users. We have a constructor. We have a stake tokens function. We have a setting price feed function, updating unique tokens. Do we have unstake? We haven't fixed unstake, but we will in a minute. Yeah, I think that's the only bit we need. So this, again, is where tests are going to help you out a lot. You write some tests, and you can actually do stuff from the tests. So let's fix our unstake tokens bit here. What do we need to fix from here? Well, we need to add this bit about the unique tokens staked. Message.sender equal, since they're unstaking all their tokens, or excuse me, they're unstaking that specific token. So we're going to remove that token from the platform. Awesome. Now, in the interest of time, I kind of want to just write my migration scripts, like copy paste. So we're gonna write the migration scripts real fast. Okay. So let's do this. In here, we're gonna do 2 deploy token.js. Actually, let's compile first. Compile. Great. We have some compilation errors. Let's go see. Did you mean IERC20? Yep, I sure did. You mean stakers? I sure did. Did you mean stakers here too? I sure did. Did you mean a real type? I sure did. Let's try to compile. And awesome. So stuff compiles. Great. So again, you definitely would want to write tests here. We're going to skip over them because we only have an hour left and we got to get to the front end. So write tests. It's gonna help you a lot more. A lot of times somebody like, oftentimes when I'm doing this stuff, I'm like, oh, I'll just skip the test. It'll be quicker for me to get to like an MVP. And it actually usually ends up taking me longer, right? Because I run into bugs, I try to fix something, and then everything gets way out of whack. So we're going to skip the tests just because I've already tested this myself. So let's go ahead and do the migration. So it's compiling. Awesome. Let's migrate some stuff. So we'll do, the const dep token. And if you're like, wait, migrations? What are you talking about here? Go watch some of those other truffle videos that we have. Artifacts.require token module.exports equals async function deployer network accounts. We'll do await deployer.deploy dep token const dep token equals await token dot deployed. We'll do like console.log token dot address. So let's go ahead and test this. And again, since I just downloaded the truffle box, if we go to the config here, we have Ganache, we have Coven. Oh, it looks like we don't have live in here. Probably should have live in here. But we have these two environment variables, mnemonic RPC URL. Here's an example. If you want to just do it in a .env, you can do like .env and then put those in there. Again, we have ours set, so we don't need to do that. If you're like, wait, well, environment variable, what are you talking about? Just kind of follow this and put it in your own .env file. So we'll do truffle, migrate, -- work Coven, and we'll see if this works. So this should run this, and we should console.log the dep token.address. Ran into an error here. Unknown error when sending transaction. There's a good chance this is actually related to this. Or recently released a bug in their hardware wallet, and I'm just going to reinstall everything. Sorry, guys. Yeah, there's a weird glitch right now. So this is good. Actually, we're going to test deploying this. I mean, and this is like a really simple ERC20. So if we can't deploy this, that's a bad sign. So we're going to re-download this stuff. Now let's go ahead and try to truffle migrate. And we'll see if we get the same error. I haven't seen this error before. So this will be, we'll do a little bit of live debugging here if this is an error. And again, the other thing about writing tests is you don't have to, finagle with, doing the testnet ETH and the testnet link. You can just run everything locally, which is great, which is why we still have these mocks in here. Yeah, so it looks like it was related to that. So yeah, Truffle released a bug recently. So if that's causing issues, just use that different version. And I might even go into the box and update that like right after this video, so that everyone just kind of starts with that older version. Cool. So we actually were able to deploy it, and this is where the address was. We can go check that out on Coven Etherscan. Yeah. So the answer to that error is just downgrading your HD wallet provider to 1.0.40. It's a really annoying truffle thing right now. So the other workaround is to just not use truffle, use hard hat or brownie. So anyways. Great. So we have this deploy script. Let's create our deploy script for the other one. And this will be deploy token farm. This one's going to be a couple more things. So I'm just going to do a little copy and pasting in the interest of time. Do this module.exports again. We're going to get the DApp token that's already deployed. We're going to deploy the token farm. We're going to send our token farm the initial starting balance here. And great. And then I'm just going to copy paste again. Sorry, guys. I'm super speeding through this just because I want to get to the front stuff. You can go check this out on the GitHub. Let's talk about what's happening here. We're saying, okay, if the network starts with Coven or it's live, if it's one of these two networks, we're going to set these. Addresses. So we're going to add allowed tokens to this token, which is the link token address, and this is the link F price feed address. So again, you can see all these in the contract addresses here. Go to Ethereum. You could also use ENS. That actually would be pretty cool. But if we scroll down to Coven, it's F. Actually, we can even just link F. So on the Coven network. So we're getting the price in F of everything so that we have something to compare it to. We're going to do FAU token as well. This is the FAU token address. We're pretending it's going to be DAI. So this is the DAI ETH. And then this is going to be our DApp token, which we're also going to be pretending it's DAI. So we have this add allowed tokens. So we're adding the allowed tokens for it. And then we're setting the price feed contracts up correctly. Okay. So we have this mapping and we know where the price feed addresses are. So let's go ahead and run this as well. Great, network Coven. And this should just deploy the token farm because Truffle should be smart enough to be like, oh yeah, you already deployed the DApp token. Let's, yeah. So it's going right for the token farm, which is good. And we are deploying. Awesome. We're getting somewhere. So now we have the backend pretty much done, and we have stuff deployed. We have stuff deployed to some good places. But when we're working with our front end, we actually want to be able to interact and work with these ABIs on the front end. So I'm actually going to create a new folder, SRC, and this is where all my front end stuff is going to be. And I'm going to create a new folder in here called ABIs. And what I want to do actually is in my Truffle config, and this is where we're slowly migrating to the front end bit, we can add what's called a builds directory or a contract build directory in here. So we can say contracts build directory is going to be SRC ABIs. In this way, our front end will actually be able to interact with this a little bit better. So now, so we have source ABIs. If we rerun this, great. Reset network Coven. We're actually going to get all of these ABIs in this source ABIs folder, right? And this will be great because we can put all our front end stuff in here. What is an ABI? ABI stands for Application Binary Interface. So if we look at these, it has this ABI section, and this is really where the ABI is. And it just shows the way to like interact with your contract, right? So it's going to say, it's going to have these, it's going to have all your events, all your function calls. It tells us, okay, here are the functions, and here's what we can do with this contract. And we need an ABI and an address in order to interact with any smart contract on chain. So, good question. So that is the ABIs, though. So awesome. So we've deployed to source ABIs. We have our backend set up. Now we can move into the front end stuff. Let's do it. Let's do some front end stuff. So I'm going to go ahead and drop in some boilerplate stuff. If you guys feel free to like just copy paste from the repo on this. This is just going to get us set up doing things for the front end. So in here, we're going to do, well, actually, once this is done, being sent. So we're going to add components, and we're going to add everything we need for our front end in this SRC. So we're going to add components, index.js. We're going to add a service worker. And it's going to be a pretty lightweight front end. It's just going to be a simple, well, simple is a terrible word. But we're just going to have a server that's going to be, yeah, like I said, running our front end once this decides it wants to finish. So yeah, we're not going to go over like all of the stuff here. We're just going to copy paste some boilerplate, just so that our lives are a little bit easier. So, okay, cool. Let's go into source there. And we're going to touch service worker.js and open that up, service worker.js. And I'm just going to paste some stuff from my GitHub. Again, just feel free to copy paste for this section. This is kind of the less important stuff. And we are also going to create an index.js. So this is going to be one of the more important parts. So it's going to be React. So we're going to do import React from React, import React DOM from React DOM. Oh, actually, yeah. Import bootstrap /this/css/ bootstrap.css. And then actually, I'm just going to go ahead and copy paste all this stuff in here. Because this is kind of this really isn't the interesting part. This is literally just some boilerplate to get started. You can literally copy paste this into your smart contract and go. The more important thing and the more interesting thing is going to be components. So now we have this components file. This is where stuff gets interesting. Okay, so we're going to have two kind of main functions. We're going to have or main files. We're going to have app.js, main.js. So let's go ahead and navbar.js. So let's go ahead and create all those. We're going to do app.js. File is going to be main.js, navbar.js. These are the different components of a React app. Yes, the navbar is going to be for the navbar, and the main and app are going to work together. Let's also create an app.css. And I'm kind of glossing over a little bit here, but stick with me, guys. So let's start doing our, which one do we want to start with first, actually? How do I get through all this in 45 minutes? That's going to be the real challenge here. It's going to be to rip through this in 45 minutes. Let's just start with main, right? Yeah, let's start with main. So we're going to, again, we're going to be doing kind of the class-based React here. So let's just go ahead and start ripping it. So we're going to do import React, component from React. Import, let's get some images in here. Actually, we could skip the images for now. Right, now we have our class main. It's going to extend component. And let's render some stuff. So this is going to be our main function that's going to be rendering our front end. So we have our render function. We're going to do return. And this is where we start writing the HTML. And this is where we write kind of the less interesting stuff. And I kind of want to just copy paste. Oh, there's some. How did I go through this in like 2 hours? So let's do div ID. Actually, yeah. How do I get through the rest of this in 40 minutes? That's going to be the real question. Which sections can I copy paste, and which sections do we want to see? Let's think about this. What's the best way to go about this? What do you guys think? How do I copy paste most of this without copy pasting stuff? Maybe we'll start with app first, actually. Yeah, I'm running a little low on time. I probably should stop being slow here. Let's start with app. Let's start with app.js. Yep, let's just start here. And let's just go. Import React component from React. Yeah, let's start here because it's going to have a lot of the contract stuff. So we're going to be using Web3 from Web3. Now we want to import the contract that we made. Yeah, I do want to copy the directory, but I don't want to copy paste this jam. You're killing. But like I don't want to like. I feel like I'm going to be skipping over a lot of stuff if I just copy paste everything. But yeah, let me know what you guys think. We're going to import it. So we're going to import our dep token, and this is why we put it into its own kind of thing. We're going to import it from ABIs/token.json. You're going to see how we're going to interact. We're going to go through app and then index or main. Excuse me, main will probably just copy paste because there's going to be a lot there. Token farm from ABI/token farm JSON. And this is one of the niceties about having your front end and back end in the same repo. We can compile, build, send it, and then our front end automatically has it available. We do import ERC20 from ABIs/ERC20.json. We're going to import navbar. Actually, we're going to skip the navbar for now. Or main from main import app.css. That's how we're going to style it, and then we're going to import, and that's it. Actually, we will have to import the navbar. Crap. Do the navbar first, actually. Then navbar from ABIs. Could you please explain ABIs and why we need it? So this is the second time, someone's asked about ABIs. So yeah, I'll go into ABIs. So ABI stands for Application Binary Interface. So if we go to if we go back to Remix, for example, right? Oh crap, I meant to update this actually. So it stands for Application Binary Interface. So this means that we have a way to interact with these smart contracts, right? When we call contracts, when we interact with contracts, we're kind of just calling these functions that are really just like bytes and stuff on chain. So when we it's a little bit easier to see when we're actually doing it. When we if I want to interact with a contract on chain and I don't know what the functions are, how am I going to interact with it, right? Like if we go to Etherscan, Coven, and we look at this, that we just deployed. Token farm address, right? Go to the contract. What do you see here? Do you see any functions? No, you see a whole bunch of stuff, right? This doesn't mean anything, right? This isn't when we're writing software, right? And we want to call a function in here. Like there's nothing here to call, right? This is just a bunch of jarbles. Like, how do we actually compute this? So we need an ABI to say, here's how we can interact with this smart contract. So an ABI is a way to like make sense of stuff. Now the ABIs are kind of dumb, and when we say, hey, this ABI belongs to this address, our code is going to say, oh, okay, well, you're the boss, great. And if we call a function based off our ABI to this contract, it's going to try to call that function on this contract. So, and if that function exists, it'll call it and we'll be successful. Great. If it doesn't exist, it'll freak out and be like, stop doing whatever you're doing. You're being nonsense. So there are two things you always need to interact with a contract that's on chain. You need the address of that contract, and you need the ABI or interface. those are the two things you always need when interacting with the contract. So keep that in mind. You need the address and you need the ABI interface. You also need the ETH1 connection, or excuse me, the ETH connection, right? You also need to know what blockchain it's on, like if it's on Coven or Rinkeby or whatever. But those are the two main things. Once you know what blockchain you're on, those are the two things you need. You need the address and you need the ABI. You need the ABI because you need to be, your code needs to know how to interact with that contract. Does that make sense? Because this is just jarble, right? Computer doesn't understand what this is. If I go back to my code and I say, hey code, this is how you interact with it. Hey code, this is what you can do. Hey code, there's a oh, excuse me, that's the, let's look at the token farm. Hey code, this contract has an owner, new owner, previous owner. Hey code, you can change ownership, you can renounce the ownership. Hey code, this has a staking balance. You can view the types of that staking balance. Hey code, it has a mapping in here. Hey code, you can add allowed tokens. Here's the inputs. So it lets us know how to actually interact with it. So good question, really good question. I'm actually just going to copy paste navbar because the navbar is not doing anything interesting. Yeah, I do need to add this as well. Cool. Hello. Yeah, we're not going to look at the app bar. App bar is not doing anything interesting. We're going to skip over that. App.js. Okay. Class app extends component, and this is just some React stuff. Again, this is class-based. The VRF pizza one that does state hooks, which is different. I recommend checking out the state hooks if you want to work with the newest stuff. So async component will mount, and this is when we load. We're going to await this dot load web3. Await this dot load blockchain data. Okay, so once we log into the page, we want to load our Web3 stuff. We want to connect to the blockchain. Okay, so how do we do that? Well, we probably need a function called load Web3. We probably need a function called load Web3. We also need a function called load blockchain data. Okay, so this is going to connect us to Web3, and this one is going to load all the blockchain data into our smart contract, into the front end. Okay, so this is, hey, once we get to the page, how do we get stuff up? So let's do this. So let's create an async function called load Web3. And this is where like knowing a lot about the how to work with Web3 kind of comes into play, and how to work with Web3 on the front end. So we're going to say if window.ethereum. So if there is like a metamask or something, that's what this means. If window.ethereum, you can learn more about this in the Web3 package. But if window.ethereum, then we're going to say window.web3 equals new web3 window.ethereum. This is how we're going to connect to the blockchain. We're going to say await window.ethereum.enable. We're kind of hard coding this. So to say, okay, the instant we get into this front end, we're going to load Web3 data. We're going to load blockchain stuff. And we're going to wait until the user hits that confirm button. What happens if I hit yarn or yarn start right now? I think I was supposed to create React app here. Uh-oh. Oh, wait, yeah. Is that where the boilerplate is? I want to test this real quick. Did I start this with create React app? I probably did. See what happens. npx create React app. Create React app. Okay to proceed. Yeah, sure. unless it deletes all my stuff. Let's do make dir tests ctsc. I'll run it. Just test it. Yeah, it's okay to proceed. So actually, if this is what we did, then everything will make a lot more sense. Actually, don't remember if I created this with create racked app. Let's find out, guys. Let's find out. There's a good chance that we did, and if we did, then that's great. So we have a new folder, src, tst. Oh, well, look at that. Public. Looks pretty much like what we were doing, huh? Well, we're gonna just delete that though. Remove RF test. So if you're looking to create a front end, I highly recommend doing like create React app as your starting point, or just copy and pasting stuff from here. But we're just gonna copy paste and we're gonna continue on. In an R package.json. I'm gonna do scripts. I'm gonna add a new one. We're gonna do start. And we're gonna do this. React scripts at start. So what happens? Command not found. Okay. Let's get the command. So we do need to add a lot of this stuff in here. Sorry, guys, I kind of bounced all over the place. HD wallet. So I'm actually going to recommend you guys do like create React app or create ETH app to get started. If you do create ETH app, you're going to get the state hooks. If you create React app, you're going to get this class-based stuff. So we're just going to copy paste over. We're going to copy paste some stuff over just so that we get everything good here. Apologies, guys. Stop the live coding. Oh no. One second. Sorry, I'm just going to grab from, oh, whoops. Going to remove this real quick. Apologies, guys. So yeah, so you're going to want to do create React app or create ETH app, and that's really going to get you guys set up. But in the interest of time, for me, like actually doing this right. So we are still going to go through app.js, but we're going to have everything else already set up for us. So create ETH app or create React app. That's kind of going to be your starting point. And then, once we did, you guys saw that once we did that kind of create React app, it populated with the different components, with the index and everything. And then you can just run yarn start from that, and that'll actually get you up to speed. So yeah, this kind of has everything already imported in it, but we're gonna pretend like we don't have anything in here. Yeah, so sorry guys, apologies there. Create React app or create ETH app. It really does explain a ton. I mean, I still know nothing, but I have much better framework in my head of where to start putting ideas. Awesome, that's great to hear. So yeah, so create React app or create ETH app. Those are two really good ways to start your front end. But yeah, sorry, I kind of jumped around a lot there. Let's put back the put back this stuff. So because this is where most of the important stuff is anyways. Actually, main is going to have a whole bunch of like HTML. Yeah, I'm not going to have enough time to go through over this anyways. Main is going to have a bunch of HTML, a bunch of JavaScript to get to like update the HTML based off the variables, and that's really it. That's really what this main page has. So let's do the app.js, yeah, because there's no way we're going to hit it all in 30 minutes. A little bit aggressive here with the timing, but so app is where the majority of the stuff happens. So in here, what are we going to do? We're going to, the instant we start, we're going to load Web3, okay? And so we're going to say if window.ethereum, we're going to do else if window.web3, window.web3 equals new if new web3 window.web3.current provider. And what this is saying, okay, if there's Ethereum here, let's enable it. Otherwise, let's just get the current provider. And so you pretty much have to have a metamask. The way we're setting this up, you have to have a metamask to set to work with this. So we're saying if they don't, we're going to do window.alert, you know, on ETH brow detected, on Web3 browser detected, maybe install MetaMask. Probably install again. So all the contracts are going to be the same. The deploy scripts are going to be the same. And we have 25 minutes to get through the rest. So I kind of, there was no way I was going to get through the rest if we're going to go through everything. So create ETH app. Create ETH app and create React app are going to be your friends. Create ETH app is going to use state hooks as opposed to this class-based stuff. But state hooks are really nice. So let's go ahead and do yarn start now, and let's see what this little bit gets us. It will get us not much, right? Pretty much nothing. Or it'll just load forever because it's like, what are you doing? What are you talking about? Yeah, well, we have an error, but MetaMask pops up right away, right? So we're actually going to go ahead and go back. Let's add this other function that we have, which is load blockchain data. Load blockchain data. And this is where we have to load, we want to load all of our contract information. Accounts web3 equals window.web3. Our accounts, const accounts equals await web3.eth.get accounts. Sorry. So if you do yarn start, it'll keep like updating. I don't want to do that quite yet. And we're going to set the state of our app here. So this is going to be the state hooks are a little bit different. We're going to use set state. So we're going to set state of our account to account 0. This dot set state of token address. We're going to initialize the front end so that they're on the link token address. And we're going to do this dot set state. So we're going to skip this part. We have to add this part. Set the image, Chainlink. This dot set state, token name to link. So what is this going to do? Actually, I'm curious what this is going to do. You're on start. It kind of break and freak out actually, because we don't have any other information. Yeah, it's going to break and freak out. I have 20 minutes to get through a lot of stuff. Let's go really fast, I guess. So what are we setting the state for? So we're setting the state so that on main.js, we can actually call this stuff. So again, main is where we do all of our HTML, right? So if we want to get the staking balance of each token, we'll on the front end, we can do this dot properties and get the token name, right? Because when we set the state, we're setting the state for our front end. Same thing with the image. Right? If we want to use a certain image, we can grab it by getting it from the properties that we set, token name, address, and everything. So let's just try to rip through the rest of this because this is kind of the important one. So we'll do const ERC20 equals new web3.eth.contract. And this is where we need that ABI, ERC20.ABI, state.token address. This dot set state to ERC20. ERC20. We're setting the ERC20 state to ERC20. So again, on the front end, actually, we don't do anything here. We'll do it on the back end stuff. And then we'll get the balance. Let ERC20 balance. Wait. ERC20 dot methods dot balance of this dot state dot account dot call. So we're going to get the balance of this ERC20 based off of the account that's connected. This way we can render it on the front end. And then we'll do this dot set state, ERC20 balance, ERC20 balance dot to string. We're getting our ERC20 balance of the account that's connected to us, and we're gonna render this on the front end. So let's keep going though. We have the balance of our ERC20. Let's do const dep token data dep token dot networks work ID. This dap token dot network says let's get the dap token data from our networks based off of the ID. Like for example, if we're on Coven, if we're on Rinkeby, if we're on whatever. And if there is data there, then let's get that data. Token equals new web3.eth contract. And again, you see we're using this web3.eth.contract, and we're going to use the dap token.ABI again. Because again, in order to interact with anything, we need the ABI, right? We need to work with the ABI and the address. Anytime we initialize a contract to interact with, ABI address, always. We'll do this dot set state token address dep token data. we're setting the DApp token. We're telling it, we're saying, hey, great, we have a DApp token here. We're also going to do this dot set state token. Now let's start getting some balances here. Let DApp token balance equals await token dot methods. I'm sorry, I'm going so fast here, guys. Balance of this dot state dot account. A call. So same thing as above. How we got the balance of the ERC20. We're gonna get the balance of the reward token. This dot set state token balance. Token balance dot toString. So now we have the we have the balance here, and then again we're going to do else alert. Say app token not deployed. So if we don't find any information, we're just going to say, hey, we have an error. Okay. So this is all for the DApp token. This is all the DApp token data here. This is all the ERC20 stuff. Now let's grab stuff for the token farm. So const token farm data. And this is all in this async load blockchain data, right? So this is just us loading all the blockchain data from our contracts. Token farm data is going to be token farm dot networks. Again, network ID, because we want the network ID. Typo balance of, thank you. Thank you. This is what I get for trying to build a whole front end in 15 minutes. Token farm data. If token farm data. Const token farm equals new web3.eth.contract. Token farm.abi. Token farm data address. Thank you, appreciate that. So again, same thing. We're getting the token farm information from the ABI and the address. Again, you're going to see this a lot. Anytime you want to interact with a contract, you're going to need to get the ABI and the address. So this dot set state farm. This dot update staking balance, and this is a function that we're going to need to do. We're going to say, okay, great. Let's get all the token farm data. Let's update the staking balance. It's going to be a function we're going to make in a little bit. And then let's do another else here, right? Else, hey, you didn't deploy the token farm. So we're loading blockchain data. We're getting all the information for whatever token that they're working with right now. Again, we're going to default them to Link. Then we're going to get the DApp token. This is going to be their rewards, right? The rewards that they need. And then we're going to get all the token farm data. And then we'll do, once this is all done, we'll set loading to false. And we'll have a loading state that we will change to true often. Okay, great. So this is going to load us all of our. We have 10 minutes left. I'm not going to get through the rest of the stuff, guys. I'm sorry. I'm going to copy paste, and we're gonna just go over. We ran out of time, team. We ran out of time. I was too slow building the contract. So let's just go ahead and run this. Copy pasted stuff back in. So let's just go over what kind of happened here, because again, we're not going to have time to kind of just code everything else. So we have a couple functions at the top here. We have component will mount. So this gets loaded whenever we like refresh, right? So we load this Web3 data, which we saw was just like basically interacting with MetaMask, and then we have this load blockchain data, which gets all of our account information. It gets all of our ERC20 information. It loads the DApp token. It loads the token farm. And then we have a couple of different functions. This stake tokens. This is how we interact with that big stake tokens button. You can see that we're, once we hit stake tokens, we're going to change loading. And on the front end, there's a loading component. It's probably in the nav bar, or it's in the CSS. I don't know. It's in the nav bar. Where's loading? When we're rendering, if this .set state is loading, we're going to add this little HTML that says loading. We have a way to change token. Whenever we click a button, that changes the different tokens. We have this function here, which gets called again from the front end. Main.js. So we kind of botched the front end here, guys. But whenever we click one of these buttons, right? If we click DApp token, we call this change token function, which changes us to that specific token. What else is in app.js? We have update balance, which gets called whenever like a transaction finishes. We can call this update balance to update these balances on the front end, right? Because we have these different balances here. Update staking balance. This is a button that we press. Excuse me, this isn't a button that we press. This again is going to update the amount of staking balance that we have. We have a whole bunch of other functions down here. Like I said, stake tokens, unstake tokens. This is this big button right here, stake and unstake. These are what gets called. These functions get called, and this constructor props thing. This is what's used so that this main can render all the variables from this app.js. And then we also have this render. If stuff is loading, we're going to add this little loading bit. And then the main content is going to be, again, we're going to say, hey, we're going to send it over to main.js. And here's what we're going to set all the like starting variables to so that main can understand stuff. And then, yeah, and this is just for the nav bar. So sorry guys that we didn't quite have enough time to like go through everything here, but let's just like look at how this works. So let's stake. Right now I'm staking 10 link. Let's stake one more link. Stake. See if we get this loading thing pop up. MetaMask is going to ask us to approve first. Once that goes through, it's going to ask us to actually confirm. And now what's happening is a transaction's going on Coven. And, oh, unless I just broke everything. Oh, well, sorry, that was actually a different local host that was running. Oh no, it's there. So let's see, did that transaction finish? Coven, looks like it did finish. Our staking balance finally went up to 11. Now, if we unstake, let's say we want to pull all of our link back, we're going to confirm. Once this finishes, the staking balance is going to go back down to 0 because we're going to unstake everything. So it looks like it finished. If we do a refresh here, it looks like it's back down to 0, which is good. And we can see our link balance went up. All right, we can see the balance of all of our tokens here. Our link balance went up. Now we don't have any reward, so let's figure out how to do that. Remember, we only give rewards if people have something staked. So let's hit stake. We'll stake some of our tokens here. Yep. And then we'll take questions. Yeah, sorry, we ran through this really quick. I recommend you guys checking out Create React app or Create ETH app to kind of get a front end going pretty quick. Create ETH app is really good. It is using state hooks. So this demo uses class-based components, which is a little bit different. But learning the state hooks will be really good. And once this transaction finishes, looks like it's still going, we'll get a staking balance, and we can call one of our scripts here. We can call issue tokens, this issue token script, and then we'll be able to see a reward here. Does this finish? Okay, great. We have 10 link stake now, right here. Let's go back to our scripts. We can run truffle, exact scripts, issue token, network coven. It's going to call our issue tokens function. That's it. Unknown network coven. Is it network live? Oops. Sorry, I converted it to live here. Network live. And this should issue tokens. This should issue rewards tokens here based off of how much 10 link costs in ETH. So sorry, I kind of bounced all over the place, but yeah, open for some questions here, guys. Hopefully, at least the first part was really helpful, kind of seeing the running process of a dApp that actually works. And again, you can absolutely fork this, do whatever you want with this, play with this, or just go right for Create ETH app and go from there. Any questions, comments here as we wait for this transaction to go through? Their link staking isn't a thing, but for this, for token farm, 0 right now. This isn't hooked up to like any other application. So this is kind of the gateway, right? Once you have people staking on your platform, then you can deposit into Aave. You can kind of do what Yearn.finance is and deposit it around. You can kind of do whatever you want once people have staked in your platform. So right now, the APY for this application is 0. Good question. And is it freaking out because I have to redeploy? Well, whenever that finishes, this will go up. Any recommendations for resources that go in depth for what you taught today? Yeah, so for the front end stuff, I would say go check out Create ETH app. This one's really good. For the truffle stuff, I mean, most of the backend stuff is actually more. I mean, you can just watch the, like Chainlink YouTube. If you go to videos, right? We've done a number of workshops on the backend stuff, right? Testing. You can go check out this video here. For the truffle stuff, we can check out here. dApp University, like I said, dApp University has a lot of really good videos. If you like videos, if you like courses like Udemy Solidity is really good. Crypto Zombies is going to be one that's really good. And this is just kind of basic Solidity stuff here. Back. That's more like basic Solidity stuff here, but for the front end stuff, yeah, create ETH app, or you can take really any React or front end course. Like for that VRF pizza, that silly VRF pizza one, I was literally I learned a lot of my React stuff from just Googling, state hooks, React front end, and then watching a bunch of videos that teach us how to do that. So the docs are really good. There's a lot of videos on some of the stuff. Yeah, I apologize we didn't go as deep in the front end stuff as we would have liked because we kind of got short on time. But yeah, there's a lot of really good resources there. Good question. Any other questions? My biggest problem is wrapping my head around linking smart contracts to a front end. Yeah, so really the piece that you really need is going to be like if you create React app or create ETH app or whatever, the biggest thing that you're really going to want to look for is having this ABI section, right? Having being able to get your ABIs, because if you look at all of our front end stuff in app.js, is we import these ABIs, right? Import token farm from ABIs.token farm, and then once you import an ABI, you can make you can interact with the contract with kind of pure JavaScript stuff, right? So const token farm equals new web3.eth.contract, pass in the ABI, pass in the address. Those are the two things that you're going to need. And once you have those, you can do whatever you want, right? So like right away, we got the token farm with the ABI, with the address, and then we called token farm.methods.staking balance, right? So we're getting the stake. So we called one of these functions. And if we remember, farm, we have, so Solidity is interesting. Oh, sorry, you guys can't see my screen. So yeah, in app.js, you need, like I said, you need the ABI and you need the address, right? That's it. Web3.eth.contract. Ethers is a pretty similar syntax. But once you have the ABI and the address, then you can just start calling functions, right? So staking balance is a function. In Solidity, like these global variables are count as functions, but we could just as easily call like stake tokens, right? And once you have this, you're good to go. So you just need the other thing that you're going to need is a Web3 connection. We do it with Web3. Web3 equals window.web3. And we do this load Web3 function, right? So if we say if window.ethereum, then we have window.web3 equal to this window.ethereum. Window.ethereum is basically saying if metamask is there, have that metamask be the connection, which is really helpful. So once you have the blockchain connection, the ABI, the address, you're good to go. And since we're dumping our ABIs to this ABIs folder, we can just, when we compile, we can just pull the ABIs right out of here. Hope that helps. That's a good question. Awesome performance. Thank you. I do apologize, though, for not getting as far through the front end stuff as I would like. I am late for a meeting, but yeah, feel free to ask questions in the Discord. Thanks, everybody, for joining, and we'll talk to you soon.